All right, let's continue topic 4. Today's video is going to cover 4.3 and 4.4. Starting with 4.3, we're going to be able to prove and apply the side angle side and side congruence criteria. What we have on the screen right now, I want you to pause the video before we move on. Answer these two questions. If you're watching this on 10/28/2020, I am not there, and this is part of your participation for the day, is to answer these questions. There's a few more throughout. I want these answered on Google Classroom. There's a Word document, and you can just put your answers number 1, number 2, and as we go through the rest of it. If you're watching this on another day for another reason, to review or just, study, thank you for being here. So let's start with Theorem 4.4. Go ahead and pause the video so you can copy it down. You'll notice the next theorem is Theorem 4.3. I put this one first because this is the foundation of what we're doing moving forward. So we're going to go to Theorem 4.3 next. Now that you've had a chance to pause the video, this is the corresponding parts of congruent triangles are congruent. Now this is really important because you're going to need this when you do your topic 2 writing assignment or your quarter 2 writing assignment. This is how you're going to prove a lot of stuff here once we use side angle side, side angle angle, or angle side congruency criteria. This is the part that lets you tell your reader that those methods, or even hypotenuse legs, so those 5 methods are valid, and that's because corresponding parts of congruent triangles are congruent. I remember this by remembering cool people can teach calculus, and that's why Mr. Finwell only teaches geometry. Right? So corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Cool people can teach calculus, and that's why I'm teaching geometry. And what this basically says is if 2 triangles are congruent, then each pair of corresponding sides is congruent, and each pair of corresponding angles is congruent. Now in 4.1, 4.2, we talked about that where if we can show that 2 of the angles or all 3 angles are congruent in both triangles, and at least one of the side lengths is congruent, then we will have 2 congruent triangles. We also showed that if we had a combination of all 3 side lengths and all 3 side lengths, then they were congruent. We did 2 side lengths and an angle, 2 angles and a side length. All of those go back to showing that those triangles were congruent, and we talked about it in class. But here's your theorem that lets you state that these are in fact true occurrences, that this will always happen this way, or that if I can show a combination of angles and sides are congruent in both triangles, then all parts of the triangles are congruent. And what it means by corresponding parts means when I map them, the parts that line up perfectly when they map onto each other. So if AB is not the same length as ZX, those are not corresponding parts. AC, because we can kind of visually see that AC is my longest side on this one and ZX is my longest side on this one, then these are in fact the corresponding parts. And if I were to rotate this and translate it here, I can see that then B and Y would go together. A would rotate up to X, C would come down to Z, and we can kind of see that following out here in our conclusion. Now, we're going to use something like the side angle side congruence criterion. And once we have this combination here, a side, an angle, and a side, we can go back and say that all parts of a triangle are congruent. Because this right here tells me that these 2 triangles are congruent. And then I know that corresponding parts of congruent triangles are congruent. So if I have side, angle, side, and we'll get more into this, but side, angle, side, then I can say that XZ and RT are also congruent by the previous theorem, Theorem 4.4, or CP-CTC. That's what I'm really going to call it. And here we have side, angle, side congruence criterion. I'm going to stop the video here so I can get my writing utensil up and we can actually look at how we would prove this. I'm going to show you a way to organize everything so that you can do this foolproof every time. All right. So let's look at exactly what this is showing in our hypothesis here, or if RS is congruent to XY, angle S is congruent to angle Y, and side ST is congruent to side YZ, that we then have side angle side congruence. So if I'm going to use side angle side congruence, I have to have my congruency markers associated in this order. This must be my first thing, this must be second, and this must be third. So what this really looks like is an angle between two sides. So let's just do that very basic look really quick. So here I have two tick marks. Here I have an angle. And then after that, I have another side length tick mark. So this is exactly what I have. I have an angle included between two sides, right? It just fits right in between those two. So I now can say I at least have side angle side. What I have to do is just make sure that these are the corresponding parts of the triangle that I have shown are congruent. And what does that mean? It simply means here, if I have triangle R, S, T, that these go in the same order as X, Y, Z. So the first thing I have is from R to S. Let's do a different color. All right, first. The first thing I have is from R to S. And here I have X to Y. So I'm going to label this number 1 and number 1. And I can see that from R to S and X to Y, I have the double tick mark. So what I'm going to do here is put in my first. I do have a side length, and it has 2 marks. Second, and now I'm going to go this direction. Now, it will be more complicated when it's not just given to you, and I will show you that. But for now, you can see the order in which I drew my arrows, and that just happens to work out for here. This is just the angle S this time. And this is just here in the middle, the angle Y. And I can see that these are also congruent. So I can say 1 angle mark. And then if I keep going in that same direction, I can't change directions now. I'm going in a clockwise on this one, and a counterclockwise here. I have to keep in that same way. So now I can look here and I can see my third piece is ST. Here I definitely have 1 tick mark, so 1 mark. And then from here, my third piece will be YZ. And that also has 1 mark. So now I have a side that has a corresponding part that's congruent. I have an angle that has a corresponding part that's congruent. And I have another side that is a corresponding part that's congruent. So I do have side angle side congruence. Now, I'm going to clear all this, and I'm going to show you an even faster way to do it. But when you're having a hard time orientating these, this little numbering system works perfect every time. Here, what I can do is, I can see that S and Y are marked the same. So if I reflect S down to here, then I will see that my parts, right, because my new corner will be down here, will line up perfectly. And I will see that I have an angle in between two sides, and that is automatically SAS. So let's look at another example, or another criterion, I believe is next. Yep. This is the side criterion, congruence criterion. I think this is the easiest one to understand. This is the easiest one to internalize, and probably the easiest one to see. SSS just means I need 3 sides that can be orientated and then mapped onto each other, and they fit perfectly. So here, let's do I'll call it the shortcut first. If I make this a line of reflection, where'd my pen go? So if I make this here a line of reflection, my A is going to flip over to here. So let's label that. So when I flip over, I know this isn't perfect, but A is here. I really just want to concentrate on the order of things. So from A to B is 1 tick mark, B to C is 2, and A to C is 3. Now these aren't lined up perfectly, right? If I just translate this down, these will not be corresponding parts that are congruent. This piece and this piece are the corresponding parts, right? They're both on the bottom. They're not congruent. However, here, these two parts are corresponding and they are congruent. But I can't go ahead and start proving this yet, or I can't say that it's been proven, because here I have my 1 tick mark on the top and my 1 on the bottom. Now when I end up in this situation, I can draw a second line of reflection that will turn this triangle over onto this one. And if I were to do that, I would end up with B here, A here, and C there, as it pretty much is in my current drawing. So now the question becomes, since I have mapped these onto their other points, if I can show that there's a 1-to-1 or that each corresponding part is congruent, then I'm good to go. The reason I did it this way is because now I can see that line BA should be the same as line DA. And you might say, well, Mr. Fimble, but that doesn't prove the triangles yet. No, but what I can do now is say that EF is the same as BC. And they conveniently both have the double tick mark. So I've shown BADA, which is the single tick mark. This is the double tick mark. And my last one would have to be FD, and that would have to be CA. And if I can show that all three of these are congruent by the congruency marks that I'm given, then I have shown that this triangle is congruent by a side-side-side congruence criterion. And then I can say, because the corresponding parts of congruent triangles are congruent, that all three angles must also be the same. And I'll elaborate on that after we do our check. How many tick marks is it from BA and DA? Well, or sorry, shouldn't be DA, it should be DE. So BA has 1 tick mark, DE has 1 tick mark, BC has 2 tick marks, EF has 2 tick marks, so we're good there, and CA has 3, and FD has 3. So I've associated these so that they are mapped onto each other, and all three of these sides are shown to be congruent with their corresponding parts also being congruent. So I can say these two triangles are exactly the same measurement. These are the exact same triangle. Now, if we go back to CPTC, or corresponding parts of CPCTC, sorry, corresponding parts of congruent triangles are congruent, what I can then say from there is that if these side lengths are all the same, then that means the angles that are opposite each one that generated them must also be the same. So I'm just going to trace back. So like E was 3, B was 3. So I can say that angle B is congruent to angle E. And look, it's starting to come out just like we said it. Angle C and angle F are the same, just like we had them drawn. And that's because they make the same. And then angle A made 2 tick marks, and angle D made 2 tick marks. So angle A and angle D are congruent as well. So now we know these are exactly the same two triangles. They just have a rigid motion, or 2 or 3 or 4, a certain number of rigid motions to get from ABC to get it to map on to DEF. So in topic 3, what we just finished at the end of quarter 1 was just saying, can we prove whether or not these are congruent? Or are these rigid motions by just showing that I can do a series of rigid motion transformations to make them map onto each other? And then we said, yes, those are the same shape. Now what we're doing is saying, without doing any of the rigid motions, Can we just look at the side lengths or angles or a combination of those two things to prove that automatically that yes, they are congruent? Well, that's what topic 4 is all about. Let's try looking at this with numbers, and I think it's even easier with numbers. What I'm going to do, just to have kind of a graphic organizer here, is I'm going to write the number of marks. I'm going to put 1, 2, 3. And then I'm going to have triangle ABC and DEF. And what I want to say is, on triangle ABC, when I have one mark, what is the side length? It's 3. So I'm going to put 3. On DEF, when I have one mark, what do I have? I have 3. So far, these are corresponding parts that are congruent. Then I'm going to look at the number of marks being 2, and I get 6 on both of them. So these are looking good for the corresponding congruent parts. Notice here, this 3 was on top, this 3 was on bottom, so I know I have to flip this figure over before I rotate it at a minimum, but I'm going to have to also flip it this way, so I'm going to have 2 reflections to get it to map on. But once I do those 2 reflections, I have 3 tick marks here, 3 tick marks here. They're both on that 5. So again, I've shown by side, side, side congruence, these are definitely the same triangle, just in different orientations, different locations. So let's look at these and determine whether or not they're congruent by side, 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 or side, angle, side. Well, I think one shortcut that we can all agree on here is if we first look at each one of these for side, 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 all we have to do is see if they have the same number of congruent tick marks, right? 1 to 1, 2 to 2, 3 to 3, or it can be an isosceles where we only have 1 tick mark and 1 tick mark. But just are they in the right order? And could we somehow do a series of rigid motions to get them to map onto each other? So here I have 1 tick mark and 1 tick mark, 2 to 2, and 3 to 3. So I have a good chance here that this is side, side, side congruence. What I must do now is think, what kind of transformations can I do here, rigid motion transformations, to get this one to map onto this one? Let's call this our pre-image, and let's call this our image. And what I want to do is this. What would I have to do to my pre-image to get it here? Well, I'm definitely going to want to rotate it, and I'm going to go this way, because this is right at the quadrant 1, 0, 1, like in my imagination. And then if I rotate it 90 degrees, this would just be at 1, 0. But I'm going in a clockwise manner, so I know I have to rotate it negative 90 degrees. And once it's rotated, I just need to slide it over. So I'm going to translate it by some unknown xy. Remember, we're just doing this in general to see if there's a rigid motion that would map it on. If I rotate this negative 90 degrees, this is going to be exactly what we have here. This is going to come down to this position. This will be on the left, just like it is here, and this will be on the top. So this is definitely good to go for side, side, side. Is there any other one that potentially could be side, side, side? Nope, I don't have this piece here or here, so that's a no-go. Again, I'm missing this side and this side, another no-go. Here and here, another no-go. So let's now move on to side, angle, side. So remember, for this, I have to start at a side, move to the very next angle, either going left, right, up, or down, but it has to go to the next angle. That angle must have a congruency mark. And then from there, going in the same order, I need to find another side with the exact same congruency mark. So here, I have 1 tick mark. I'll put 1 T for tick. If I go in this fashion, I'm doing that so I know that I'm going from 1 tick mark, 2 tick marks, 3 tick marks, right? I have at least 3 pieces of information, which is exactly what we need. Back to inductive reasoning, 3 pieces of information. If I go from here, the next thing I encounter is an angle with 1 tick mark, and then I get a side with 2 tick marks. So if I follow this in order, I do end up with side, angle, side. Now I have to know, can I do the same thing? But this time I need to go one tick mark, one angle mark, double tick mark. So that means I'm going to go this direction. And I think we can see that for this one, we're also going to get one tick mark, one angle mark. The order obviously doesn't matter. Think of this as multiplying. And after I go from one tick mark to one angle mark, I'm back up to 2 tick marks. So I can see I got these in the exact same order. So I definitely have a side, angle, side, congruence. This is without a doubt. Now let's look at this one on the bottom left. I'll go to a different color just so, because we are going to be working pretty close to one we've already done. So here's the first time we're going to come up with something you cannot do. This is a big no. If you start here, and I want to go this way, within 2 moves, that's one angle and one side, I must have another congruency mark. If I'm going this way, I don't have an angle congruency marker here, and I don't have a side congruency marker here. I cannot go in this direction. Okay? Please put that in your notes. If you start on a side length, you have to land on another tick mark within 2 moves. That a side must be followed by an angle of congruency for the 2 triangles, or another side length. If you have to skip an angle and a side length to get to an angle marker, this is not the way you can go. You must turn around and try it the other way. So let's do that. Now if I go here and I go this way to get here, I don't have a marker here. So I must have a side marker next and then an angle marker. So this is good, except for here I'm going to end up with side, side, angle. And I can see I can follow that because now I have that foundation. I need to go from one side mark to 2 side marks to 1 angle mark. And I have side, side, angle. Now, I put this in green because I want you guys to know this. We are going to learn 5 congruency criterion. So far we know side, 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 angle, side. You will not ever, at any point in this class or in your future mathematical career, ever use a bad word in this class or a bad word spelled backwards. That is the easiest way to know what you're going to exclude from your answer choices. If you ever see, just like we showed here, this bad word spelled backwards or forwards, so SSA forwards or backwards, is never allowed. I don't use exclamation points very often, so let me stress that again. SSA or ASS will never, at any point in any math class, no matter what you hear, if those will never work. SSA, ASS, never an option. Right? And I'll show you why when we get to the similarity chapter. We're actually going to use that in that chapter, but SSA, forwards or backwards, is never a congruency criterion. Okay? So one more time. Forwards or backwards, this bad word is not allowed in this class, period. No exceptions, no questions asked other than, after I said this so many times, the only question left is, why did you choose this as an answer? Or why did you try and use this as a criterion of congruency? This never works. All right. So now with that being said, let's go to our last one. This time, I'm going to start here at 2. That's a side. If I travel this way, I immediately hit an angle. And then if I travel this way, I immediately hit a side. This is more of your flow chart, where what I did on the first 2, right, the first one is just side, 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 really easy to see. And then we could do our rigid motion transformations. Here, I've just made a chart, and then I compared my chart, kind of like our truth table. Since they're exactly the same, I said side, angle, side. Here, I'm starting at 2 tick marks, and I'm flowing towards the angle, and then I immediately flow towards the side. Here I have 2 tick marks for where I started. Here I have an angle, and here I have the single tick mark from where I ended up. So this is SAS. Now some of you are going to be watching, especially if this is a video, this is a question I hear often. What if I started at the other way, Mr. Fimble? What if I started at 1 tick mark, headed to the angle, and headed back? Start at one tick mark, head to the angle, head to the double line. Don't we get the exact same answer? So one of the nice things about these are these can be read forwards or backwards as long as you're not using a bad word. Side, side, side can go either way. Side, angle, side, if you're doing it right, will also work in both directions. So some of you may choose to start at angle marker 2, some may choose to start at angle marker 1, but you're going to get the same answer if you go in the right order every time. So that's pretty much it in action. Notice here I typed out cannot be determined. That's fine too, but I would just say SSA, ASS are never allowed. Those do not determine any form of congruency in this class or at any time in the future. So this is the end of 4.2. We had theorems 4.3 and 4.4 from it. They didn't give you 4.4 in the summary, but that is really corresponding parts of congruent triangles are congruent. It's what you're really going to need when you're writing your proofs. Now, we're going to get plenty of chances to see those in action. We're going to see those in our homework. We're going to see those in class. So you'll get to see it. But that one's really important. If you're stuck and you're kind of getting towards your proof where you're proving any of these congruency criterion, once you've shown at least 3 pieces of information, the side, angle, side, 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 angle, or angle, angle, side, which are the next 2 we're going to learn, or the hypotenuse leg, if any of those work, then you're going to say this is true by corresponding parts of congruent triangles are congruent. And just one more time, that means the way I remember it is cool people can teach calculus, and this is why Mr. Fimble teaches geometry. So cool people can teach calculus, and this stands for corresponding parts of congruent triangles are congruent. CPCTC is a little much to remember. This corresponding congruent is a bit confusing to remember. So cool people can teach calculus is easy to remember, and then you can kind of get it filled out. Just remember congruent always goes for the last 2 C's. So here's a few for you guys to practice. This is going into your Google Classroom assignment. It's a Google Doc. You're just going to put question number 3, and you're going to answer A, B, C, or D. Here we go with this one. Pause the video, read it, solve it, and then we're going to move on. Again, put these in your answers in that document. Be careful here. This is asking for side, side, side congruency criterion. So that means these angles being congruent really isn't going to help you because we're not looking at any kind of angle congruency. So select all that apply for this one. And I'm going to actually do this one with you on the video because this one's a bit interesting. What is the value of x? Well, I have to look at these 2 triangles and determine, are they congruent first? So number 1. Are they congruent? And if they are, what are the corresponding parts? And once I do those 2 things, it's just basic algebra. So can I prove these are congruent? Well, if I come here, this is the side. If I go this way, and I'm doing this on purpose, I don't have an angle here, and I don't have a side length of congruency here, so this is not the way I can go. I must go this way. And I'm going from a side to an angle to a side. So now if I start at tick mark 1, move to this, I have a side to an angle, which leads to a side, and they are orientated in the same way. I'm traveling from tick mark 1 to angle 1 to tick mark 2, tick mark 1 to angle 1. So these are congruent, yes, by SAS, side, angle, side. So what are the corresponding parts? Well, BA and whatever has the 1 tick mark, DE, are congruent and corresponding. Then I know that angle A is congruent to angle D and corresponding. And then I know that DF is congruent to AC or CA, it doesn't matter. So those are my congruent parts. What does that do to help me? Well, nothing yet, except for now I need to recognize that if these are congruent by SAS, then the corresponding parts of congruent triangles are congruent. This is what I meant by CPCTC being so important in your proofs. If I know those three parts are congruent, then all the other parts of this triangle that are corresponding are congruent. So really easily, I know this side, that's my third side, is congruent to this one's third side. I'm not going to even worry about the angles at this point because I already see something coming out of this. And that is simply this. X minus 4 is equal to 19. But let's get the x minus 4 down before we get to the equals 19. So I can then solve for x equals 23. All right. So my important questions are the triangles congruent? Yes. By which criteria? Side, angle, side. Now that I know they're congruent by side, angle, side, I need to be able to match the corresponding parts. So I'm going to do this really quick just for number 2 as an aside. I'm going to draw it smaller, but like we know, we cannot trust our eyes. So here I would have this mark, and that would give me D. And then if I were to just flip this up, B would come down here, and C would come down here. C, let's see, A to C. Wait, why do I have a D on here? Oh, because I drew it as that up there. This is an A. So this triangle is just this run reflected and then translated to here, so I can see that they're oriented the same way. This is now A. A to B has 1 tick mark. A to C has 2 tick marks. So now I can see that if I flipped it over, right, like this line of reflection, I would actually end up with these mapping perfectly onto each other. So now that I know that, I know that this x minus 4 is also going to be equal to 19, and I can move on from there. And we've already kind of said some of this stuff, but we can then fill out the rest. If I did do this reflection, my B would come to E, and my C would be at F, and D and A would be congruent. So we've already actually shown that through side, angle, side, and everything else. So this is just a really tedious and not necessary check. But if I have spare time on the test, I will come back every time to do my rigid motion transformation check. And if I can make these congruency marks that I'm given map onto the congruency marks of the image, so from pre-image with ABC over to the image with DEF, if I can figure out during the test, once I've answered all the questions and I have time to review, a series of rigid motion transformations that will map my pre-image to my image, then I know that I have proven this to be congruent correctly, and any math I've done would also be correct. I guess I should have cleared that first. So let's pull this back up. And now we have angle, side, angle congruence. Well, it's going to follow the same rules, but this time we're going to have 2 angles, and in between those 2 angles, a side mark. So I'm going to call this the included side, and that doesn't make me a vocabulary master of geometry. After I said it, I just looked over here and it says the included side. Anytime you see the word included side just means it's in between 2 of your given congruent angles. All right, so you'll never guess what an included angle is. An included angle is the angle that's in between 2 of your congruent given sides. But let's look at what it means by an included side. So here, if I start at angle 1, and I'd say this is my first move, and I go towards angle 2, this will be my third piece. My second piece of information must be this side. So I went from an angle to a side to an angle, so I do have ASA. I can do the same here. From 1 to 1 to 2, this gives me an angle, a side, and an angle. The included side is this right here. It's that middle piece. It's also, as you can see, the side in between two angles. So included just means the part stuck in between two pieces. All right. Mr. Velasquez's classroom is the included classroom of mine and Mr. Johanson's, right? He's in between the two of us. So if you wrote it out this way, you would have F V J. Johanson does not start. All right, so Velasquez is the included classroom because he's between Fimbo and Johansson. All right. So included side is the side between two angles that are given, and the included angle is the side, or is the angle in between two sides. ASA congruence is done the exact same way as ASA, SAS, SSS. So let's try one of these together, and I'm going to assume it's going to want us to somehow do angle side angle congruency. But right now I'm looking at this, and all I see is this 52. So let's see if reading this question helps at all. The technician installs cables from a cell phone tower to the ground. So, okay, they've labeled cables for us. That's what I was going to come and do. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirements? So we do have two triangles here, right? We have the triangle created by, what's going to be a good standout color here? So our first triangle is this one, and our second triangle is this one. And if I can show that those two triangles are congruent, that would force us to be able to say this. This is our goal, that those two are congruent, because that's the only way to pass the inspection. So let's look at what do we have. Well, I know this is 52, and this is 90, and if this is 90, this is 90 because it's perpendicular to the ground. So if I go this way, I can say that we have an angle, a side, hopefully, right? We'd have to figure out a way to prove it, but I'm just thinking this one through, and an angle. I'm running into that problem. Here's two steps with not enough information. That means we can't move on. So this means going in this direction is 100% out of the question. So now I need to say, is there a way I can go from here to here and get some sort of congruency that we've learned? Well, if we go back to thinking this as two very different, or two separate triangles, let me put this in red. All right, so here's triangle 1 in red, and I'm going to put it in a nice green. Then we have a second triangle here. All right, so if I consider these as two triangles, let me see if I can get a black screen. Nope. Okay. So if I look at these two triangles, and I would say, what way would I prove their congruence? Well, I can start either here at the 52, so I'm going to mark that as number 1, and let's do it in a different color. Let's go blue. Nope, the background's blue. Purple. So they both have these congruency marks, so I'm going to call this first and first. Now, I have an angle, so I can make that angle and this angle second. They're corresponding, right? They're both the ground piece that's perpendicular. But I don't know that this and this is true, do I? And I can't assume that, and I can't make anything up. So I have to think, what else can I do? Well, let me ask you here. This tower, whether it's in the red triangle or the green triangle, is the same as itself, right? And what I mean is, what color do I have? Okay, let's go to red. Here, when I have my red triangle, this part here is the tower. And then when I look at my green triangle, this part's the tower. So if they're both using the tower, and the tower is always equal to itself, whether it's part of the red or the green, through the reflexive property, which we've talked about a couple times, but our reflexive, talked about it more times than I've spelled it correctly. So our reflexive property tells us the height of the tower is equal to the height of the tower. Common sense, right? But now that we're doing congruency, we can separate these and say this now. We know that this was our first, right? Because those are both 52 degrees. And now we know these are the same. This is our second, because the side lengths are congruent. And then these 90-degree angles are third. So now if I write these out in order, from first to second to third, I get angle, side, angle, right? Because that tower is always equal to itself, whether it's in the red triangle or in the green triangle. It doesn't actually matter. It's just equal to itself by the reflexive property. So now we have angle, side, angle. And we can then say that by the corresponding parts of congruent triangles being congruent, that the hypotenuse of both of these triangles must be equal. And that leads us to know that the cable is therefore the same length in both. And it does meet the requirements to pass the installation. All right. Next up, we have angle, angle, side. So remember, this doesn't spell a bad word. Doesn't even come close, right? It's AAS, and we're okay with AAS. Again, they kind of set this up to be a little easier than you would expect normally. But if I start here, I would have to go this way to get to my third piece. So this would have to be my second, and this would have to be my third. So let's do that again. We're starting at angle marker 1, and we're ending at side marker 1. This gives me angle, angle, side, which is exactly what I get here, angle, angle, side. So first, second, third, angle, angle, side. And we are good to go from there. Now again, some of you might say, but Mr. Fimbo, I'd rather go from side marker 1 to angle marker 1. Well, is that going to change your answer? Yes, but no, right? If I start here and I go in this positive rotation to get here, this is going to give me side, angle, angle. Same here. Just get a side, angle, angle. So side, angle, angle lets me get to my point here that before I said, let me put this in red since it's bad. Side, side, angle never works, forwards or backwards. Do not do this, right? It doesn't work forwards or backwards. All of these congruence criterion can be read forwards or backwards. Angle, angle, side is equal to side, angle, angle. But why ask you to memorize twice as many things as you need to? If you can just remember angle, angle, side, side, angle, side, 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 angle, side, angle, and hypotenuse leg, and you know they're reversible, then you have everything you need in only 4 symmetric or flippable or reversible congruency criterion. And then you have the hypotenuse leg, which just comes out of nowhere on its own. All right. So right now we can use, let's put these in green because they're good. Side, 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 angle, side, angle, side, angle, and that's an M in there for some reason. Angle, angle, side. All right. These are the 4 that you need to memorize for your test, for your quiz, for your homework. Those are the 4 that we're going to typically use. And we're going to tap on this one later, not today. But make sure you know that you can always use these 5, but you have better not ever try any bad words forwards or backwards. And I know I keep saying that, but every year when I ask a student, what's the number one thing you remember? They say you can't use bad words in geometry forwards or backwards. it happened this week when I said we're going to be doing congruency stuff, and they said, oh yeah, make sure you tell them not to do that. And it's really the easiest way to remember. If you make a little joke out of it, then you know every combination of S's and A's here in green. If you accidentally put that one in red, just read them forwards and backwards. And if it's a word you can't say at school, get it off your list because it's not an option for you. What we're going to actually do here is kind of see how this, in a very special case, can be this. But that's Friday's lesson. So let's talk about these. Let's call this number 1, number 2, number 3, number 4. I'm going to do number 4. Number 4, I have an angle here, I have an angle here, and I have a side. Now if I start here at the double angle, because that was first, it needs to be first here, then the next angle, and then the side. So this gives me yes by angle, angle, side. We know that one's allowed. It's even up there in the directions to state whether or not each pair is congruent. So I'm going to say absolutely yes to number 4. And since I took that one, I'm also going to take number 2. I'll do the odd ones. You guys can do the even ones. Number 2, super easy, right? Just ask myself, can I map my pre-image on my image? Do I know which one's my pre-image or which one's intended to be? No, I get to pick. So what I'm going to do is imagine that I'm rotating this point to here, and I'm going to try and imagine where everything else would end up. So if this comes all the way over here, then this one's got to come all the way up here, and this one's got to go all the way around to here. So yes, by side, side, side. Yes, by side, side, side. Those are not 8s. Those are side, side, side. So on your document, I need questions 1 and 3 answered. All right. All this is showing you here, simply put, so I had this weird shaped quadrilateral. And I think that's probably the best name we can give this, right? Just 4 sides. And I'm not sure if it's congruent or not. But I can draw this through the middle. And now I've created 2 triangles. Can I map these on to here, right? So does this little triangle with side, angle, side map to this triangle? Well, side, angle, side. So this whole part is good to go. Here I have side 1 tick mark, double tick mark, triple side tick mark. 1 side tick mark, double angle mark, triple. Yeah, these two, this triangle is congruent to this triangle. So that means all of its corresponding parts are congruent. These 2 are congruent, so all of their corresponding parts are congruent. And in a funny way, we also know 1, 2, 3, 4, that since all corresponding parts of congruent triangles are congruent, and by the reflexive property AC on triangle ABC and ACD are congruent, we are good to go by side, angle, side. And this would just be a straight up translation, wouldn't it? To keep it even simpler, we would just translate something positive x and y is going to be 0. Here are your last 2 theorems for 4.3. Try this one on your own without help and see what you come up with. So your homework is going to be on savasrealize.com. It is section 4.3 and 4.4. They're due the day after your class meets at 11:59 p.m. We are in quarter 2 now. We've had time to settle in to e-learning and hybrid with face-to-face. So no late assignments will be accepted under any circumstances other than extended time accommodations or an excused absence.